Good morning everyone. Today we will see about the analysis and design of a flange beam or T-beam. Myself Dr. J. Sagarvan, Professor and Head, Department of Civil Engineering, Rohini College of Engineering and Technology. This is actually a structural system. Normally the structural system consists of this column. These are the column. This is called primary beams. This is a primary beams. This is a secondary beam. Normally the secondary beam connected with the primary beams. This is a top view of our structural system. This is the top. We have the slab. This is a primary beams. These are the columns. Let us take this section. If we cut the structure like this, we will get the section like this. This is a L beam in the corner. Two corners we have the L beam. In between we have the T beam or flange beam. Normally the structure is cast monolithically. Slab as well as beam cast monolithically. We will get a T beam. Normally intermediate section we have the T beam. In the end we have the T beam. In this structure we have the two L beam section as well as two T beam section. Let us see what is a flange beam. So normally that flange beam consists of two portions. One is a flange portion, another one is a web portion. So this is a T beam section. So this is a flange portion. This is called a web portion. In a structure we cast the section like slab as well as beam in monolithically. So we will get a T beam like a structure. So this is a rectangular beam. The slab is above the rectangular beam. It is like this structure. We will get a T beam section. Let us see what is T beam. The T beam is the beam normally in a design consideration which can be taken to a designer advantage when the slab and beam are cast monolithically. Both are cast in a monolithical manner. This is actually that it consists of flange portion. It is having a web portion. Actually the web portion is extended up to the flange portion. This two portion is called a flange. The designer have the advantage for T-beam in the wide flange that has got on both sides of the web. This gives the additional strength to the normal conventional beam. The T-beam is given in IS 456 class 23.1. Let us see about the T-beam section and codal provisions, what the codal provision says. This is actual the T-beam. Depth of the section is called DF and width of the section is called BF. This is BW is width of the web portion. This is a web portion. From IS 456 2000 23.1.2, the effective width of the flange is given. Normally, due in the bending, the maximum of flange is not taken part of it. Some of the portion only take care of the bending moment. So this is given clearly given in 23.1.2. In the absence of more accurate determination, the effective width of the flange may be taken as the following, but in no case greater than the breadth of the web plus the half the sum of the clear distance to the adjacent beam of the either side. For a T-beam calculation, we have to find out the BF value like L0 by 6 plus BW plus 6 into DF. L0 nothing, that distance between the point of zero moment in the beam. BW already we discussed, breadth of the web, and DF is the thickness of the flange. For the L beam section, the value of BF is calculated by L0 divided by 12 plus BW plus 3 into DF. For isolated beam, the effective flange width shall be obtained by the following. The value is not greater than the actual width. For the T beam section, BF is equal to L0 by L0 divided by B plus B4 plus BW. For L beam section, half of this one, that is 0.5 L naught divided by L naught by B plus 4 plus BW. Now let us see how we can calculate this L naught. L naught nothing, the distance between the point of zero movement, where the zero movement will be happen in a beam. Suppose if we take this simply supported beam, this UDL is acting like this one. This is a bending moment diagram, parabolic, where that zeroth movement in the support here and here as well as here. So L naught will be nothing but that effective span. Let us take this continuous beam. This is a bending moment diagram for a continuous beam. Okay, maybe bending moment happen like this only, where that zeroth movement here and this part here, this part here and here. Okay, so the L naught is the distance between point of zero movement. So okay, so here to this one. Okay, so the L naught value will be is equal to from this portion to this portion. Okay, so I hope you understand how we can measure the L naught value. Okay, this is all about TB. Thank you so much.